So, alrighty, so the green sheet is going to be for you to refer to, but we're still going to fill out these notes so that I can at least give you a basic explanation for everything that we're about to do with these. So before I write some more on this, rectilinear motion describes an object that travels in a line. So it's rectilinear as in rectangular. So the X and Y plane is called the rectangular plane because everything moves left and right and up and down. And that's why they call it the rectangular plane, because I guess left, right, up, down plane is really wordy. So objects that travel in a line. S of t is the original function, and it gives the coordinates of point P. And then this is where we use your notes from last night where you guys looked at what happens if you take another derivative of something. So if you have like the original position of something and you take the derivative of that, that gives you the velocity. So the velocity of P is written as v of t, and v of t is the derivative of s of t. How many of you guys have taken any sort of physics class? So we know that velocity is kind of like a speed, but it has a direction, right? You can have like a negative velocity, that means you're going backwards. A positive velocity means you're going forwards. So if we want to know the speed of P, then we're going to take the absolute value of the velocity. So because we're talking about something that can go right and left, we're talking about something that can go backwards. So if I say negative 5 miles per hour, that makes sense because I just mean it's going to the left instead of to the right. Okay? So we're talking velocity there. All right, acceleration of P is written as a of t, and the acceleration of t is the derivative of the velocity, which is the second derivative of the position. So acceleration is a rate of change of a rate of change. Second derivative. So it's an acceleration is a rate of change of a rate of change. So you could be driving 35 miles per hour. That is your instantaneous rate of change. When you are currently driving on the road and your speedometer says 35 miles per hour, that's how fast you're driving. That's your instantaneous rate of change. But if you've got your foot on the gas and you're going faster, then you're accelerating at whatever miles per hour squared, because you're accelerating as you're currently moving. So it's a rate of change of a rate of change. Does that make sense? Okay. So this idea of a second derivative is something that you do every day that you drive in your car. It's very regular. It's also something you do often when you walk. When you're walking somewhere, the speed that you're walking at is your first derivative, but if you speed up or slow down, that's your second derivative. Your rate of change is changing. That's the second derivative. Okay? Does that make sense? Yeah, so your acceleration is positive if you are accelerating. It's negative if you're decelerating. All right, so then we talk about something, an object speeding up. And we talk about objects that are slowing down. So this is talking about the actual object moving, because if you are accelerating in a negative direction, then you're going to be slowing down. because you are quickly going slower, if that makes sense. You're accelerating in a negative direction. If you're accelerating in a positive direction, and you are quickly speeding up. Okay? So the way that you look at speeding up and slowing down, and this I think is an idea, it's a little bit abstract. It's kind of like the idea of a double negative almost. It'll mess with your head for a little bit. So we're going to write it down as something that we maybe memorize at first. But I think as you do these problems over time, then you start to understand them better. I will find for me, this is a hard thing for me to explain well as a teacher. This is a weak spot for me to explain. The nice thing about it is you can memorize it and do it right. Okay, and it's not too hard. So you know that you are speeding up if the velocity and the acceleration have the same sign. So if the velocity is positive and the acceleration is positive, then the object itself is gonna speed up. If your velocity is negative and your acceleration is negative, then this particle is gonna look like it's speeding up. It's just doing so in a negative direction. Okay? The object itself is going to be slowing down if the velocity and the acceleration have opposite signs. And we are spending a whole day on this, and you are getting that green sheet on this because these are some really favorite multiple choice questions on the AP exam. They love asking questions about rectilinear motion because it makes you do the derivative, it makes you do a second derivative or a third derivative, it makes you interpret it in a certain context, you have to understand units. It's just kind of like a good problem. It catches a lot of things. And so it's problems they like to do, okay, which is why we're going to spend a whole day on it. Okay, does that stuff make sense so far? Okay, so here is our first example problem. We are going to take the equation, the position equation, S of t equals t to the third minus 12t squared plus 36t minus 20. And we are going to describe the motion of P on the interval -1, 9. So S of t represents the position of the particle. The t stands for time. T stands for time and is typically in seconds. So yes, our interval is -1 second to 9 seconds, which I understand is an abstract idea, but they work with that for these points. So your t is not necessarily always only positive. We're going to go back in time to do this problem. I don't know why they're cool with that, but they are. Yes, sir. It's typically brackets, but it could be parentheses.
Doesn't matter.
It matters as far as writing some of your answers, whether you would include the number or not. Yes. Yes. There, in theory, there could be a hole, but there's not. There could be. We're not going to deal with it on this particular problem because our position equation is a polynomial, and polynomials don't have holes. But if your position equation had a rational function, then you definitely could have a hole.
So
You typically see it with polynomials or something like this. I've never seen one with a hole, but it's possible.
So if the interval they give you has a unit of
I've never seen them do that. Yeah. So these are more about the interpretation of the problem. They don't necessarily try to trick you up a whole bunch. They just want to know if you can do it. Okay. So first, I'm going to write down my original equation, and I'm going to write down my first derivative, which is my velocity, and my second derivative, which is my acceleration. So what would our velocity equation be? 3t squared. Perfect. And if that is our velocity, then what's our acceleration?
6.6
Mm-hmm.
minus 24.
Perfect.
Wait, so what is the point in finding two derivatives?
Because they're going to ask us questions about velocity, and they're going to ask us questions about the acceleration.
You just use and plug in different equations.
Yes. Okay. So if they want to know about the motion on the interval, when I give you guys questions to do, I'm going to tell you specific things I want you to find. So the velocity is like you're just driving normal. You're not going faster or slower. You're just at a constant rate. That's like you set your cruise control and you're just driving down the highway. Okay. So if we want to know when the particle is not moving at all, then we need to take the velocity and set it equal to 0. Okay? So I'm going to take my velocity equation and I'm going to say 0 equals 3t squared minus 24t plus 36. And it's a quadratic, so how do we typically solve those? Factor, right? So I have a GCF of 3. I'm going to go ahead and take that out. If it had not been factorable, how would you have solved it then? What if you didn't have a calculator?
Say it again.
Oh, you
So-
said a quadratic formula.
Quadratic formula. So if this is not a calculator active problem, then you would use the quadratic formula or you would factor to solve for these. If it was calculator active, you could just graph it on your calculator and find what the x-intercepts are. Okay? Slide divide is a type of factoring. All right, so now we are looking for two things that multiply to positive 12, but add to a negative 8. Okay, so t minus 6 and t minus 2. So what are the solutions? Positive 6, positive 2. So that means that at 6 seconds exactly and at 2 seconds exactly, the particle is not moving at all. It has a velocity of 0. Okay? Because t is time. The 3 is a GCF, and because it didn't have a t attached to it, it's not considered a solution. If it had a t with it, then we would say that t value is 0. Okay. So this is where v of t equals 0. So the particle is not moving. All right, and then this is something that we're going to do quite often in this class. We're going to draw a number line. 2 and 6. And we're going to see, sorry, that keeps swapping. We're going to see what the signs are to the left of 2 and in between 2 and 6 and to the right of 6, because it's going to give us more information about how the particle is moving. So what is a number that shows up to the left of 2 on the number line? 1. And I'm going to go ahead, I'm going to put negative 1 right here. I'm going to fill that in. Why am I filling that in?
Because it's a bracket.
Because it's a bracket. And then I'm putting a 9 there also with a bracket because that was part of our interval. Hello. Oh, thank you. I have a phone now because I'm legit. Yeah. Appreciate it.
You just plug it into one of your random.
Marvelous. Thank you. All right. So you guys said we wanted to plug in 1. So if we plug in 1, we have 3, right? Which is a positive number. 1 minus 6 is negative. Yep. Negative 5, which is negative. 1 minus 2 is negative. So if I have a positive times a negative times a negative, I get a positive. So when the time is between negative 1 and 2, my velocity is positive. That means that my particle is moving in a positive direction, which means it's moving to the right.
Wait, so why did you plug in 1?
Because it was between negative 1 and 2. goes to the left of 2. 2 is a number where I know the particle is not moving at all.
Okay.
So now when I plugged in a number to the left of 2, I can see that between the time of -1 and 2, the particle was moving in a positive direction. It had a positive velocity, which means the particle is moving to the right at that time. Yes? Yeah. So we picked a number between -1 and 2, and then you can plug it in to this velocity equation if you want, but I find it a little bit easier to plug it in right here because I don't care what the number is for the velocity, I only care what sign it is. So the 3 was positive, 1 minus 6 is negative, 1 minus 2 is negative. So if I do a positive times a negative, overall that's going to be a positive number, whatever it happens to be. Okay. Now we're going to choose a number between 2 and 6. 4. All right. So the 3 again is positive, so I'm going to write a plus down. 4 minus 6, negative. 4 minus 2, positive. Okay? So positive times positive is negative. That means that between seconds 2 and 6, the particle was moving to the left. It's moving, it has a negative velocity, which means it's moving to the left. All right, what's the number between 6 and 9? 7. Okay, so we have the 3 again, so that's still positive. 7 minus 6, positive. 7 minus 2, positive. A positive times a positive times a positive, positive. All right, so based off this information, I'm going to say that the particle is moving to the right from -1 to 2 and from 6 to 9. I'm not including 2 and I'm not including 6 because the particle was not moving at those moments. That's where it paused because it was turning around to head back the other direction. All right, the particle was moving left from 2 to 6. These intervals were all the t values based on our time. Yes. Yes.
If from 2 to 6 it was positive, would you just do bracket
if this in between had been positive, then you would have said -1 to 2, parenthesis 2 to 6, parenthesis 6 to 9, because we had to know that it was not moving at 2 to 6. Any other questions? Yes.
So, will they ever ask you to like put your answer based off of like what if you want if they wanted you to find something with acceleration, you would do the exact same thing?
Yeah, we're about to do the acceleration.
Okay.
Okay. So next, we want to know about the particle's acceleration. Okay. So we're going to take the acceleration formula that we have. We want to know when it is not accelerating at all. So I'm going to take 6t minus 24, and I'm going to set it equal to 0.
You said when is it not accelerating?
That'll tell me when the speed is constant, when it's not speeding up and it's not slowing down. The speed is just constant. This is cruise control. So how do we solve that? Plus 24. So you can do it two ways. You can add the 24 to the other side and say 6t equals 24. Or you can factor it just like you did with the other one. Take out a 6 and then you have t minus 4. Or over here you could divide by 6. And if you divide by 6, you get t equals 4. And if you did it the method where you factored it to find the answer, you get t equals 4. Both of those are a good way to do it. Okay? They both work. So on our number line, the only value that we have is 4. And when we talk about acceleration and deceleration, we are not going to call that speeding up and slowing down. We are going to call it acceleration and deceleration. Because speeding up and slowing down doesn't talk about accelerating, it talks about acceleration and velocity together. Does that make sense? Okay? So we are going to say at 4, the acceleration is 0. The acceleration is 0. That means the speed is constant. Whatever speed it was going is constant. Okay, so we're going to do the same thing again. Again, we have this -1 right here and +9 right here. If they didn't give you an interval, then you would do -infinity to +infinity. Okay, it would work the same. All right, what's the number between -1 and 4? 2. So if we do 6, that's positive. 2 minus 4 is negative. So we've got a positive times a negative, which is negative. So what do we know about the particle from -1 to 4? Decelerating. Okay? Does anyone know how to spell decelerating? Two C's? Decelerating? Does that look right? Decelerating? Okay. It is decelerating from -1 to 4. Yep, not bracket. Don't copy that. Parenthesis. Okay. All right. And then what's the number between 4 and 9? 7. Marvelous. All right, so the 6 is still positive. 7 minus 4 is positive. And so what is happening at that time? Accelerating. I know.
It has 1 C.
Oh, it's X.
Accelerating has 1 C?
Decelerating.
Decelerating has 1, but accelerating has 2?
Yes.
Marvelous.
It's accelerating.
Okay. Yes. If you did this way, then you could just plug in 7. 6 times 7 is 42. 42 minus 24 is positive. 6 times 2 is 12. 12 minus 24 is negative. You just need to overall know what the sign is. I don't really care what the number is. I just care. Yeah, so guys, just to clarify, when you plug this in, it's not that there are right ways and wrong ways to plug it in, it's that there are ways that are easier to do without a calculator. So when I'm plugging numbers into the factors, I'm doing that because I'm lazy, and I don't care what the number is, I only care what the sign is. And it's easier for me to do that without a calculator if I just do it with the factors, because the factors are always small. Okay. All right, so what we need to do now is we're going to combine those two number lines together. Are you listening? We are going to combine those two number lines together because we want to know when the velocity and the acceleration are acting together in such a way that they make the particle speed up, or acting in such a way that they make the particle slow down. Okay? So what I'm going to do is I'm going to combine these two number lines. So first, I'm going to go ahead and put all the numbers on one number line. So I've got 2 and 4 and 6, and it starts at -1 and it ends at 9. I'm combining both of them together. So what I'm going to do is I'm going to take the symbols from the velocity and I'm going to put those symbols on top of my number line. So from -1 to 2 is positive. From 2 to 6 is negative. And from 6 to 9 is positive. You guys see how I did that? So I'm just taking all the numbers from velocity and all the numbers from acceleration, and I'm drawing them on one number line. Okay?
Okay.
So on the top, I did my velocity signs. Here the particle is moving right, the particle's moving left, the particle's moving left, the particle's moving right. Does that make sense? Yes.
From 4 to 9 on the acceleration one, it's positive. So
Yes. We're going to do the acceleration signs on the bottom. Okay? So for the acceleration, from -1 to 4, it was negative. So -1 to 4, we have negative. From 4 to 9, we have positive.
So on the top is velocity, bottom is.
Top is velocity, bottom is acceleration. And this is how we can do our speeding up and slowing down. Because speeding up happens when the signs are the same. Slowing down happens when the signs are opposite. Okay? So here, what's happening in here? Speeding up. You are decelerating in a negative direction, which gives the appearance of the particle moving faster. You are decelerating in the negative direction, so it gives the particle an appearance of moving faster. So the particle is speeding up. Over here, a positive and a positive, the particle was already driving fast, now it's driving faster, so it's speeding up. Okay? So we are going to say that the particle is speeding up. Sorry, I want to make sure I hit all my notes. Speeding up from 2 to 4. And 6 to 9. The particle is slowing down when? -1 to 2, 4 to 6. Okay. When we answer these questions on the AP exam, if we have them for an FRQ, and there's a pretty good chance you will have one as an FRQ, these are called sign charts, and they are not a valid answer. So what you will say is you will say the acceleration and velocity have the same sign, therefore they are speeding up. The acceleration and velocity have the same sign, therefore I know it's speeding up from 2 to 4 and 6 to 9. The acceleration and the velocity have opposite signs, therefore they are slowing down from -1 to 2 and 4 to 6. Yes?
So you can draw the chart.
You can draw the chart, but when you justify, and you are writing an answer for a mathematician, you can't use the sign chart to justify, you have to use mathematical words.
Okay, so you can't just write speeding up and slowing down.
Speeding up and slowing down are like actual phrases that we use, but your justification for knowing that's what they're doing is that your velocity and your acceleration have the same sign, or opposite signs. Yep. And when we look back and we answer those questions about moving left and moving right, you're going to say the velocity was positive, therefore it moved right. The velocity was negative, therefore it moved left. You can't refer to your sign chart and say you had a plus or a minus. Okay? You can say your acceleration was negative, therefore it was decelerating. Your acceleration was positive, therefore it was accelerating. Okay? Does that make sense how we justify using mathematical language? Okay? So the sign chart is for us. It is not for the AP grader. The AP grader is a mathematician, and they need you to write it as a mathematician would. Okay? That make sense? We don't have to cross it out. It's common for kids to write it, but if you use it as your justification, you will get no points. Okay? All right. There are 2 more things we want to look at. So if we want to know the total distance that we traveled, we have to keep in mind that we went to the right, and we went to the left, and we went to the right. We backtracked a little bit. Does that make sense? Okay. So if you think about it like this, I live in Raleigh, I drive 20 miles to work every day. I know, it's rough. So if I want to look at the total distance I traveled, my total distance is 40 miles a day. My displacement, how far I am from home, that's 20 miles. Does that make sense? So total distance is going left and right, back and forth. Displacement is just how far are you from the beginning. Does that make sense? Okay. So to find the total distance, we are going to start with a t value of -1 because that's where we started. And we have to consider those moments where we changed directions. Those moments where we change directions are easy to find because they're the factors that we used to solve when we did the velocity. Those are the movements where it stops moving left or right at all and it's just 0. So our two numbers there were 2 and 6. That's where you stopped moving and you switched directions. And then we have to end at 9. So here's where you get to use your calculator. I want you to take your calculator out and plug in the S of t equation. You can plug it into y equals. That way you can just look at the table to get your answers rather quickly. Yep. So if you plug in -1, what do you get? So if you are graphing it, then you can look at your table. You can do second graph and just look at where x equals -1. Make sure your parentheses are in the right. Yeah, it should be -69. If you just plugged it in on your normal screen and you didn't graph it. Oh, hit second. One of them is table set. You can change where your table starts. It's in the blue though. You see where it says table set? Yeah, so second that one, and then you can change and make your table start at 0. All right, what happens if you plug in 2? You get 12. If you're looking at the table, it doesn't matter because we don't actually want to see the graph. We just want to look at the table and get the values. What happens if you plug in 6? -20. What happens if you plug in 60? Or what happens if you plug in 9? 61. I said it. Okay. So if you have moved from -69, you're left 69, and then you go all the way to right 12. How far have you gone? You've gone 69 spaces to the right, and then 12 more spaces to the right. You've gone 81 spaces total. If you were at 12 to the right and you went all the way back to 20 to the left, how many spaces have you gone? 32. If you were to the left 20 and you went all the way to the right 61, how far have you gone? 81. Okay, so we just need to add those up to find our total distance. So 81 plus 32 plus 81. All right, so our total distance. So this includes some backtracking. We went back and forth. Our total distance is 194 units. If you want to put units of measurement on this, we would literally call it units because these are the little boxes on your graph. So overall you went 194 boxes. You went left and right when you did it, but you went back and forth 194 boxes total. Yeah, this includes you going back and forth. The other one is displacement. So displacement, we're going to do this one next. This is where we do end minus beginning. So total distance is like me saying I drive 40 miles a day. My displacement is I say I'm 20 miles from home right now. Okay? So to find the displacement, we do our end minus our beginning. So we're going to do 61 minus -69. Because our beginning place was 69 places to the left, and our ending spot was 61 places to the right. So if we do end minus beginning, we get 130. That's our total displacement. That's how far we are at the very end of the problem compared to where we were at the beginning of the problem. It's possible they could be the same, but it's not possible for it to be different. Yes? Displacement is how far are you from where you were. So if you say that you started the day at the beginning of the school, like right at the front doors, I could say I'm however many 100 feet away from that. But if I say how much total distance did you travel today, you walked all around the school, you might have traveled 5 miles today. But your displacement is just how far are you from the front door.
So what if it was like the distance from 12 to 61?
You just subtract them. 61 minus 12. Say it again. You could say you backtrack because you moved all around. So total distance is like if I'm keeping track of you, however far you walk all day long. I'm constantly, that's like your Fitbit keeping track of your steps. But if I'm asking what your displacement is, I'm just saying how far are you from home at any given time. Okay. Does that make sense? Okay.